All right, ladies and gentlemen, so today we're going to start talking more and more about this unit rate and what it does for us. And we're going to start using it more in equations. So just as a review, some reminders. So a constant is talking about a unique number. And it's not changing. Right? Something that's constant doesn't change. A variable is a letter that represents a number. We know that from our algebra chapter. We also have what now we're going to be talking about something called a constant of proportionality. And a constant of proportionality is the number you multiply to get from one quantity to the other. And here's the best part, it's also called the unit rate. It's another name for unit rate. So we dealt with unit rate in the first part of the chapter. Now we're saying, guess what? It has another name. It's also called the constant of proportionality. So let's go through and look at our examples here. So wildlife conservationists are concerned that the deer population might not be constant across the national forest. The scientists found, and they give us all this information. Do conservationists need to be worried? Well, first of all, why does it matter? Why would it matter if the deer population was not constant? Well, we would worry about food supply, right? If one part of the forest has more deer than another, that part of the forest isn't going to have as much food available per deer. You might also worry about having overpopulation. Right? If the population is too big, that's when the deer start going out into different areas and stuff, and there's accidents and so on and so forth. So those are two examples. So what is the population density? That's another way of saying how many deer are there per square foot. So we have our numbers up here. So we're going to take, we have 144 divided by 16. So we're going to find the unit rates. We have 117 divided by 13. And we have 216 divided by 24. We could have created a chart. That would have been okay as well. But when I go through and divide these all out, they all turn out to be 9. So the unit rate of deer per 1 square mile is 9. Constant of proportionality. Explain the meaning of the constant of proportionality in the problem. It means that there are 9 deer per square mile. Now we don't know if that's a good number or a bad number, but at least it's consistent throughout the entire forest. Use the unit rate of deer per square mile to determine how many deer there are for every 207 square miles. So we're going to take and multiply, because it's 9 deer for 1. So times 207 is going to give me 1,863 deer. And, excuse me, for part D, use the unit rate to determine the number of square miles. So this is now where we would have to divide by the number of deer, which would give us 54 square miles. So we can use that unit rate to help us solve these different types of problems. All right, let's try the next one. So Brandon came home from school and informed his mother that he had volunteered to make cookies for his entire grade level. He needs 3 cookies each of the 96 students in 7th grade. Unfortunately, he needs the cookies the very next day. I hope none of you have ever done that to your parent. Brandon and his mother determined that they can fit 36 cookies on 2 cookie sheets. Is the number of cookies proportional to the number of cookie sheets? So that's what we're trying to compare here. So we're going to take, and this time I am going to make a chart. So we're going to have the number of sheets, and we're going to compare that to the number of cookies. And we know they told us up here that I can fit 36 cookies on 2 cookie sheets. So 2 sheets gives me 36 cookies. So 4 sheets would give me 72. 8 sheets would give me 144. So what I'm looking for, right, we did this before, is it proportional? So I have to check my unit rates for these. 36 divided by 2 is 18, 72 divided by 4 is 18, 144 divided by 8 is 18. So is it proportional? Yes. How do I know that? Because the unit rates are all the same. Another name for that unit rate is constant of proportionality. So the unit rate is 18 cookies. Actually, I'm going to write that down a little bit. So my unit rate is 18. Explain the meaning of the unit rate or of the constant of proportionality. Remember, they mean the same thing. In the context of the problem. Well, the context of the problem is just saying that I want to use my labels. So this means 18 cookies per sheet. It takes 2 hours to bake 8 sheets of cookies. If Brandon and his mother began baking at 4 p.m., will they finish baking the cookies? Well, we first have to know how many cookies they need. And at the top of the page, it told us that he needs 3 cookies for each of the 96 students. So 3 times 96 means he needs 288 cookies altogether. I'm going to take and figure out, well, how many sheets will that take? So I'm going to take my 288 cookies and divide it by 18, because I can fit 18 per sheet, and that's going to give me 16 sheets. Well, I know it takes 2 hours to bake 8, which means it's going to take 4 hours to bake. But that's not what they asked. They want to know, when will he be done? He begins at 4 more hours, he'll be done at 8 p.m. All right. Suzette and Margot want to prepare crepes for all of the students in their French class. That was very nice of them. I'm assuming that that is their French names. And there we go. Okay. And we know to make 20 crepes with a certain amount of flour, milk, and 2 eggs. Girls already know they have plenty of flour and milk to make 50 crepes, but they need to determine the number of eggs they will need. Considering the amount of eggs necessary to make the crepes, what is the constant of proportionality? So I know 20 crepes takes 2 eggs. So what's my constant of proportionality? 10. 10 crepes per egg. Okay, what does the constant of proportionality mean in the context? I already wrote it up there. It means 10 crepes per egg. How many eggs are needed to make 50 crepes? So I'm going to take my 50 crepes and I'm going to divide it by my 10, my unit rate. So I'm going to need 5 eggs. This time they didn't ask us if I have enough eggs because they apparently didn't want to know that right now. But any questions? So we're basically saying our little summation here is that the constant of proportionality is the same as the unit rate. They mean the exact same thing in a proportional relationship. Any questions? Bring them to class. Have a good night, guys.